This problem states that there's a gas mixture containing 5 kilograms of N2 and 10 kilograms of O2 and asks us to determine the average molar mass and the gas constant. So first thing we're going to do is go to test calcs, and it's a system state because it's probably in a closed chamber. And then we're going to assume PG model, so we'll go to the NPG model. Go to test app or test calcs, and just enter your mixture for mixture A. It gave it to us in kilograms. It could have given us in kilmoles or percent by mass, but we'll keep it as kilograms. And it said 5 kilograms of nitrogen and 10 kilograms of oxygen. So we'll add those to our mixture. And the first thing that our question asked was the average molar mass, which is given right here as 30.55 kilograms per kilmole. So there's our answer for A. And then it asked for our gas constant, which I don't see on here, so we'll go to state panel. And it's set as mixture A, and we'll just hit calculate. And there's our gas constant, R1. It's about 0.272 kilojoules per kilogram Kelvin. So there's our answers for A and B. We also, maybe it would have given us like pressure and temperature. Let's just guess that it gave us 100 kPa and 300 Kelvin. If we hit calculate, it would give us all our other properties that we may need for a more difficult problem. The second part of the question asks, what would the average molar mass be if the gas mixture instead contained 10 kilograms of N2 and 5 kilograms of O2? So same thing. We'll go back, maybe we'll make a new mixture, so we'll go to the composition panel, and let's make a new mixture B. This time it's 5 kilograms of O2 and 10 kilograms of N2. So we'll add that. And there we are. Our new molar mass is 29.23 kilograms per kilomole. And then we could go back to the state panel. And if we wanted to find all the other properties, we could just switch this to mixture B up in the right corner and hit calculate. And there's a new R value, 0.284 or 285 kilojoules per kilogram Kelvin. You can see that it gives you all of the ratios and all of the other properties you might need down here, and back on the composition panel it gives you like the mass ratio and the molar ratio. So pretty much anything you would need for a more difficult problem you have given. This problem could also be solved using the binary PG model. So that would be system states, PG+PG, test app, and then we'll enter our fluids. Fluid A, we'll just arbitrarily pick the N2, and then fluid B would be the O2. So for state 1, we're gonna assume that, or act as though it's just the N2 by itself. So we were given that it's 5 kilograms of nitrogen, and then the molar fraction of, or mass fraction of fluid A would then be 1, since it's all nitrogen. So calculate, you can see we get the molar mass and gas constant calculated for that state. State 2 is going to be as if it was just O2, so we were given that that's 10 kilograms. And then the mass fraction of fluid A, which is the N2, would be 0 because it's all O2, no N2. Calculate. Right, and then state 3 is going to be our mixture, so mass 3 would be M1 plus M2. And then the molar mass fraction, of N2 would be the mass of nitrogen divided by the total mass. Hit calculate, and we get our molar mass of 30.55 kilograms per kilomole, and our gas constant of about 0.27 kilojoules per kilogram Kelvin, which is the same answer as we got with the NPG model. The next part asked if we switched the two fluids, so 5 kilograms of O2 and 10 kilograms of N2. So we'll just switch that really quick to 10. Calculate. 5, calculate, and then we can hit super calculate to recalculate all the states. And in state 3, we now have a molar mass of about 29.22, which is also what we got with the NPG model.